morning, fellow mathematicians. Welcome back to another video. You know, once we reach the end of a playlist, we be doing practice sessions here on this channel. And here's your chance to try everything out on your own. 4 exercises yet again. Try them out and stop the video. And after you're done, keep watching the video for the solution. Fresh Toad Walker reference. Your stop begins now. I'll see you in a second. We are going to dive right in. So at first calculate or simplify as much as possible. And we are going to start with 2 divided by 4/5. And here we have the infamous double dot notation where I said that I don't like it. I don't like it, but you're going to find it a lot in your school life, so we might as well cover it yet again. So what happens if we divide by a fraction? Think back. Okay, so the first part stood how it stands there, okay, and then instead of division we are going to multiply, but multiply by what? It's going to be the reciprocal. So 5/4 turns into 4/5 turns into 5/4. Now I spoiled everything. And now we are basically at the point where we can just multiply this whole number, this integer, onto the numerator, leaving us overall with 2 times 5/4. And now we need to simplify as much as possible, meaning we're going to take a look at the 4. What is 4 exactly? Well, as a product of prime factors, this is going to be 2 times 2, meaning the 2 and 2 is going to cancel out, and what we are going to be left with is just 5/2. And thus we are done with this exercise. Let us continue with the next one. 3 times 1/2. Well, by the definition of a fraction, so we have talked about this in the first episode. By the way, if you don't know about anything we are doing here, take a look into the description. There will be a link to the corresponding playlist about fractions. 3 times 1/2 is nothing but 3/2. And both 3 and 2 are prime numbers, and thus we are done. This is already a completely simplified fraction. Of course, you could turn this into a mixed fraction if you're an absolute badass. Okay, so 3/2 is thus nothing but 1 whole thing plus 1/2. So as a mixed fraction, 1 and the 1/2, okay? Now, next up is 1 plus -2/5. And now here comes the episode before this episode in, or like 2 episodes ago. We talked about what happens if we divide by negative numbers. And what we found out was that basically this is just -1 times -1, because you can rewrite -2 as -1 times 2. Same should be down here, -1 times 5, and -1 is going to cancel out as a common factor. Meaning overall, the negatives are going to cancel out. Now we are just going to be left with an easy fraction addition here. Now what are we going to do to add fractions together? Well, we are going to expand the other part that is not expanded yet. So 1 needs to be expanded such that we get a common denominator. What's the common denominator? Well, obviously it's 5 here. Meaning we are going to expand our 1 by 5/5. So this is 5/5 times 1 is just 5/5 plus 2/5. It's going to give us, well, something over 5. And what is the something? Well, 5 plus 2 is 7. And thus we are done. I'm going to put a little divider into here. I'm terribly sorry, not much space left here on the chalkboard. Now we can continue with the next exercise. 3 plus 4/2. There are a lot of ways you could approach this problem, but there's one that might come in quite natural. We don't really need fraction addition here, to be honest. What you just need to see is that 4 is nothing but 2 times 2, yet again. So 4 is 2 times 2, meaning 2 and 2 is going to cancel out, leaving us with 3 plus 2/1. 2/1 is nothing but 2, so 3 plus 2 is nothing but 5, and thus we're done. That was easy, right? Now next up is a complex fraction, 1/2 divided by 4/3. How can we approach this problem? Well, how did we do it before? Well, we have rewritten this complex fraction into division notation basically. So what we had is that this is nothing but 1/2 divided by 4/3. Hey, and it now makes way more sense, to be honest, because now we can just make use of the reciprocal technique yet again. Meaning overall, this is 1/2, the front stays how it is. Instead of division, we are going to multiply. So multiply by the reciprocal, so 3/4. Leaving us overall with, well, 1 times 3 is nothing but 3 over, and 2 times 4 is 8. And thus we are done with this. There's nothing to cancel out or simplify anymore, it just is what it is. Now, 3/7 plus 1 whole thing and 2/3. That's a bit trickier here, but at first let us rewrite this mixed fraction that we are having here. So at first we are going to be left with 3 over 7 plus, and the mixed fraction is nothing but 1 whole plus 2/3. Now we can continue from this point onwards. I mean, now it's basically just fraction addition. We are going to expand our 1 at first by 3 over 3. It really doesn't matter, you can also expand it by 7 over 7. You just need to bring it onto some kind of common denominator at first. So we are going to expand it by 3 over 3, for example, leaving us with 3 over 3 here. Now we can add fractions together. So this part right here is going to turn into, what's the common denominator? Well, 3 obviously, and 3 plus 2 is nothing but 5. Okay, cool thing. Now we can continue adding fractions together. What we are having right now is 3 over 7 plus 5 over 3. Now we need to find the common denominator, and now we just need to find the least common multiple, basically, and this is going to be 21. Meaning we are going to expand this left-hand fraction by 3 over 3, because 3 is our denominator here, and the right-hand fraction by 7 over 7, because 7 is the denominator we are having here. Leaving us overall with, I'm going to get rid of this right here, leaving us with 3 over 7 multiplied with 3 over 3, plus, and then 5 over 3 multiplied with 7 over 7. Common denominator is going to be 21. This is what we have just gathered. 21 is the least common multiple of those two numbers. And 3 times 3 is 9. Plus 7 times 5 is going to give us 35. And overall 9 plus 35 is nothing but 44. Leaving us overall with 44 over 21. And this is already a completely reduced fraction. This fraction is irreducible because 21, its prime factorization is 3 times 7, and 44 is an even number, so 2 times 22, and 22 is 2 times 11, so they don't share any common factors, and thus we are done. Now, what about this next one? 2/3 minus 4 over negative 3. Well, now think back to the video I have done a few days ago. What happened if we divided by a negative number? Well, what we basically did was we were dragging our negative sign up here into the numerator. This was the first step. And then we can treat the negative sign like we can bring it to the front, because it's just a factor of -1. Meaning overall, our negative and negative is basically going to cancel out to a positive sign. And that's really easy because we now have our common denominator as being 3 already, so we don't need to expand any fractions here. And 2 plus 4 is nothing but 6. But we are not done yet because we have 6 out of 3 pieces, meaning 6 is nothing but 2 times 3. And the 3's are going to cancel out, leaving us overall with 2 over 1, namely 2, as being the answer. And those are the solutions to those questions, and I hope you got everything right. Now we are going to continue. Rewrite into improper fractions. Those are all mixed fractions right here, with one special one that we have not talked about before basically, but it's not too hard to be honest. And think back what an improper fraction was. This was just a fraction where the numerator was greater than our denominator. Meaning, for example, 13 over 7 is an improper fraction because 13 is greater than 7. That's basically it. Meaning, what we need to do, we need to expand each and every mixed fraction here and then add everything together, and thus we are done basically. Meaning 3 and 1/2 is going to be 3 whole plus 1/2. Okay, now we can just expand 3 by, what's the common denominator here? Well, 2 obviously. We are going to expand it by 2 over 2, so 3 times 2 over 2 plus 1/2. 3 times 2 over 2 is going to be 6 over 2. We're going to drag the 3 up here. 3 times 2 is 6. So 6 plus, and then 1. Okay, we are going to add those fractions together. Over 2 is going to give us 7 over 2. I hope you could see what I did here. So 3 up here is going to give us 6 over 2 plus 1/2. And then we have 2 as the common denominator. 6 plus 1 is going to give us 7, and thus we are done. Next up is a tiny bit more tricky. It's a tricky fellow here because we have a negative sign in front. But I want you guys to remember something. If we have a negative sign in front of a number, so negative a basically, this is nothing but -1 times a. Or to put it simpler, we can use the associative laws to put parentheses around it. Makes matters way easier because now we just have -1 times something positive in here. And now just keep your parentheses and your negative sign at all costs all the time, and then we can start adding together. So 1 and 4/7, 1 whole and 4/7 are nothing but 1 plus 4/7. And we can just keep expand fractions here. So our common denominator is going to be 7, so we are going to expand 1 by 7/7. Now we can add stuff together. Negative sign in front, now you can basically stop using parentheses. So 7 is the common denominator, and 7 plus 4 is going to give us 11. -11/7, that rhymed perfectly, is going to be the answer to this. Next up is 5 whole things and 5/5. At first, rewriting the mixed fraction is going to give us 5 plus 5/5. Now, here's one cool thing. 5/5 is a situation where we have a/a. That was basically a to the 0th power. And that is 1 by definition. Meaning if you have 5 out of 5 pieces of a cake, you have your whole cake lying around. Meaning this is, strictly speaking, nothing but 5 plus 1. And this is obviously 6 in the natural numbers. But we are not done yet, strictly speaking, because we need to convert those into improper fractions. Meaning 6 is thus nothing but 6 wholes, so 6/1. And thus we are done. I hope we got everything correct. Let us continue with the next exercise. Reduce these fractions as far as possible. As much as possible, as far as possible, whatever, doesn't matter. I hope you get where I'm going at. So 7/5, what is this exactly? Well, we have talked about this before. That's quite easy. We had 7/5 here as an answer, and I said before that this is a completely reduced fraction. It's irreducible because 7 and 5 are already prime numbers. So yeah, we are done with this. Nice. Now we have 3/6. We kind of covered this before too, because I can't remember where it was, but we had this somewhere here already. Yeah, we had 6/3, and what was the common factor cancelling out? Well, it was obviously the 3 here. So we can rewrite 3/6 as being nothing but 3/2 times 3, meaning 3 and 3 is going to cancel out, leaving us with 1/2 after everything. And that's basically it. 28/16, that's a bit more tricky. We need to take a look at the prime factorization yet again. Now, both are even numbers, meaning they are divisible by 2. So we need to ask ourselves the question, what times 2 is going to give us 28, for example? Well, that's obviously 14. Same should be down here. What times 2 is going to give us 16? Well, 2 times 8, obviously. And we can continue this. 14 is an even number, so what times 2 gives us 14? Well, that's obviously 7. Same should be down here. What times 2 is going to give us 8? Well, obviously 4. Hey, and that's pretty good, right? Now we have products of things, top and bottom. All the 2's are going to cancel out, leaving us with 7/4 as being the final answer, and thus we are done. Now we had a situation here that we just had. So what was 5/5 again? Where there was just 1, am I right? So 6/6 is the same situation here. It's going to give us 1, and thus we are done. So what about 5 times 3/10? Let us rewrite everything at first. Let us bring the 5 into the numerator. This is 5 times 3 over, and now 10. 10 is a composite number, meaning it consists of a product of prime factors. So what are those exactly? 10 is an even number, meaning what times 2 gives us 10? Well, obviously 5. So 5 times 2 is going to give us 10. Now you can see the 5's are going to cancel out as factors. Now we are going to get 3/2. And thus we are done with this. Now let us go for the last exercise. Order the following fractions from biggest to smallest, smallest to biggest, whatsoever. 1/5, -3/2, -5/2, 7/19, and 13/8. And that's actually not too hard, but we are going to talk about everything here. So at first, I want you guys to notice something. We have talked about this before. What were to happen if you have $2, for example, and on the other hand you have $3 of debt? So where do you have more money? Obviously, if you have money, then you have more money than if you don't have any money, right? Meaning, if you translate this to this problem, if you have positive numbers, then they are obviously greater than the negative numbers in some way. Meaning, those two negative numbers in some way are going to go to the back, alright? Just because they are negative, they are on the number line, far on the left in some way. And then we have 3 positive numbers that we need to sort out. So meaning, those 2 are going to come somewhere here, after this order relation, okay, in the last two spots in some way. We need to order them by their sizes. And other than that, we have those other three boys right here that we just need to sort out. Meaning we are going to sort out those three positive ones, and after that the negative ones, and then we are basically done. So the first step was already to separate those, because it's easy to see. Now there's one other thing that's really easy to see. What do we have here? We've talked about this before. Take a look at this. 7 over 2, for example, numerator was bigger than the denominator. 13 over 8, numerator is greater than the denominator. Meaning that's an improper fraction. And what was one key point of, or one key property of improper fractions? Well, namely that they are greater than 1. 13 over 8 is one whole cake and some other stuff. But what about 7 over 19? Well, that's not even one whole cake. This is 7 out of 19 pieces of one cake. Meaning 13 over 8 as an improper fraction is definitely bigger than 7 over 19, just because this is 0 dot something. Same spiel here. 1/5 is definitely less than our 13 over 8, just because this right here is a proper fraction. Meaning our 13 over 8 overall is the biggest number that we are having here. Okay, this is good. Now we just need to sort out 7 over 19 and 1/5. Which one is actually greater? And for this we are going to make use of the algorithm I have presented to you before. Meaning we are going to compare 1/5 and 7 over 19. And at this point we don't know which one is greater or which one is less. So we are just going to keep it how it is. Now we are going to eliminate our denominators one after another. So at first we are going to multiply both sides by 5, for example, to get rid of this denominator. Meaning we are going to get 5 times 1/5 is obviously just 1. Is greater or less? We don't know yet. Then, okay, 5 times 7 over 19. We got rid of one denominator. Let us continue this process to get rid of the last denominator. Meaning we need to multiply both sides by 19. Leaving us with, okay, 19 times 1 is going to give us just 19 on this side. Being greater or less than, okay, 5 times 7 over 19 times 19. We are going to get rid of the 19. They are going to cancel out, leaving us with 5 times 7. And 5 times 7 is nothing but 35. And now we just need to answer the question, which one is bigger, 35 or 19? Well, obviously 35. Meaning 35 is greater than 19, right is greater than left. Meaning here, right is greater than left. And lastly, 7 over 19 is greater than 1/5. Meaning we can track this into here. 7/19 comes before 13 over 8. And before that comes 1/5. Okay, we are done with this. This is good. And now we just need to sort out those negative numbers. On the one hand, you could work with improper fractions here. Namely because both are improper fractions in a way, and you could compare those on number line. But I would like to make use of just what we have here. Yet again, just go through the calculations because it's a really easy algorithm, and I want you guys to practice it a tiny little bit more. So what about negative 5 over 2, 5 over 2? Being greater or less, we don't know yet. And negative 3 over 2. So obviously we're going to get rid of the denominators one by one yet again. So what are the denominators that we want to get rid of? Well, 2, this is good. We can just multiply both sides by 2 to get rid of our 1/2 basically. Meaning overall, if we were to multiply both sides by 2, 1/2 and 2 is going to cancel out to negative 5, being greater or less than, well, negative 3. Now we just need to take a look at the number line yet again to see which one is greater than the other one. So here's 0 somewhere, and here's negative 3, obviously. Okay, negative 3 comes before 0, and then negative 5, which comes before negative 3. Meaning, since negative 3 is a bit more on the right than negative 5, that means that negative 3 is indeed greater than negative 5. And now we can track this up there. Right is greater than left. Meaning, negative 3 over 2 is greater than negative 5 over 2. So negative 3 over 2 comes here, and negative 5 over 2 comes here. And this concludes our exercise. So I would enjoy this video if you did, besides subscribe, recommend channel flag. If you know about someone who needs some maths help, then feel free to tell them about this channel, maybe also your teacher, and maybe they are going to get a tiny little kick out of it. And up until next video, I'm wishing you guys a flammable day. Ciao!